All right, peeps, this one's for you, mostly because I have a cute outfit today, but also because I know that some of you wanted to kind of see me writing these notes, right? So today we're going to start out and do it together on this video. See how you like it. If we can go back to the video where I'm just showing my notebook, that's great. If not, this is for you. If I mess up, we're just going to keep on going. We're not pausing. I'm not editing. I'm not rewriting this whole story. So we're going to try our best. We're going to get through this together, and we're going to move on to section 1.2, measuring matter. So our title right there is measuring matter for unit 1.2. When we're talking about measuring matter, we have to first talk about the fact that we know that matter can be measured, and we know that there are several ways that we can measure. What are some of the things that we're looking to measure? Things like mass, things like length, and things like volume, which is the amount of kind of space an object takes up in the amount of space that it's in and the stuff that's inside of it, okay? So in making some measurements of matter, we have to understand that there are two different types of observations that we can make. The first type of observation we can make is a qualitative observation. Qualitative qualities. We're thinking about things that we can describe. When we think about different qualitative observations, what we have to recognize is that these are observations that can be made using your 5 senses. So that's what I'm going to be writing on the board. Observations made with your 5 senses. Go ahead and copy that in your notes as well. So for an example, if we were to have an apple drawn on the board, so we know that these are our observations made with our 5 senses. If we were to draw an apple on the board, just wait while I get my red marker out here. If we're drawing an apple on the board here, and we had an apple in real life, we would make some qualitative observations about the qualities of that apple using our 5 senses. So when we talk about our 5 senses, we know that we have sight, we have taste, or smell, because those often go together. What you smell is often a similar thing to what you taste. We also have our touch, things that we can feel with our hands, and we also have our hearing. So for an apple, sight is the easiest qualitative observation that we can make. We know that apples are round and red, so we're going to use those 2 descriptive words to describe our apple or to make our observation. Notice that a lot of the words that I'm going to use in a qualitative observation are descriptor words. Taste and smell. When we think about an apple, my favorite kind are those red delicious apples, and they taste and smell sweet. For a touch, we know that apples are hard, they're sturdy. If your apple is soft, please throw it away. That means it's bad, and I don't want you eating that kind of stuff. So for touch, we're going to say it's a hard apple. And for hearing, we're going to take a nice big bite of that apple, and we hear a crunch sound. So for hearing, I hear a crunch when I bite down into my apple. So again, observations are made with your 5 senses when we're talking about qualitative observations. They're qualities, they're descriptor words. Now let's talk about quantitative observations. Quantitative. So quantitative is spelled Quantitative. For those of you who can't quite see the board perfectly in this image. So when we're talking about quantitative observations, I'm actually going to move you closer so that you can see a little better. Okay. When we're talking about quantitative observations, we're talking about the quantity of something. And we know that word from math, right? Quantity is the amount, the number. We can get a numerical understanding. So when we're talking about quantitative observations, they are measurable and numerical. So quantitative observations are observations that are measurable and numerical. So these observations have numbers assigned to them, right? These are not things that we can just be like, oh yeah, I quantified that apple weighs really heavy, right? That is a qualitative observation. There's no number assigned to it. As soon as we assign a number to it, we now have a quantitative observation. So some examples that we can make with a quantitative observation. Let's take our apple again as our example here. So we've got this here, and this is a balance scale. Some of you might recognize this from science class. Some of you might be working with these for the first time. My balance scale looks a little janky, but you'll see in my notes it's a little bit more put together. So when we put an apple on a balance scale, we'll be able to see the weight of that apple and the mass of that apple. And if you remember from the last time that we spoke, when we're talking about the difference between mass and weight, mass is the amount of stuff inside something. It never, ever changes. Weight changes based on the force of gravity that you're experiencing. So the weight that you have on here, on the Earth, is different than the weight that you have on Mars. It's just about the force of gravity, okay? So when we're making some observations that are measurable and numerical, we want to measure three different things. We're looking for mass, we're looking for length or height, and we're also looking for that volume. So when we talk about the mass of an apple, most people will measure the mass of an apple either in grams or in kilograms. And in science, we always need to make sure that we're using the metric units, which we'll touch base on in a second. So the average mass of an apple, when we put it on a scale, is 75 grams. That's my example there for the mass of an apple. Then we're going to talk about the height of an apple. This is a measurement of length. Width and height are both measurements of length. It just depends on which way you turn your ruler for that. When you look at a ruler, the way that we're going to measure in science is we're specifically looking at that centimeters portion of the ruler. So let's make sure we do that. When we measure the height of an apple, the apple that Miss Perez keeps in her classroom is typically 10 centimeters high. Decent size. And finally, we have volume. And remember, volume is all about the amount of space something takes up. So when we're looking at volume, we're going to look at multiple dimensions. And in measuring the volume of this apple, we're going to use displacement because it's a round-sized object. And we'll talk about displacement in a hot second. But first, just to give you an example of the volume measurement that we are going to use of this apple, we're going to say it's 180 centimeters cubed. 180 centimeters cubed. So just depending on how you find that volume, you're either going to use centimeters cubed or you're going to use liters, which we're going to talk about right now. Yay! So that's all of our information about qualitative versus quantitative, and we are going to move on now to the metric system. I'm going to pause the video. We're going to erase the board because you don't need to watch me erase the board. That's kind of boring. And then we're going to jump on to the metric system. Okay, here we are, moving right along with the metric system. What? The metric system is the scientific system that we use to make measurements. We recognize that in the United States, we're literally the only super weird country that measures things differently than the rest of the world. So obviously, we need to do a little bit of catching up. But as scientists, we are going to make sure that we use a universal system of measurement that can be shared with others. The whole reason reason that we do this is so that we can share our data and our information with kids from China, with kids from Japan, with kids from Australia. Everyone uses the same kind of system so that our data is measurable across countries and we don't have to do a bunch of conversions to make it understandable and translatable across languages and across cultures. So with the metric system, right here, the metric system, we have 3 different things that we're going to talk about the way we measure these things. So the first thing we're going to talk about is mass, how we measure mass in the metric system. We're also going to talk about how we measure grams. Oh shoot, not grams, see? We're just going to keep going. Instead of grams, how we measure. Oh, wait. Oh, my God. Okay. Wipe all of that. We measure mass in grams, which is why I was getting confused. Just bear with me. Be my friend. Love me for who I am. So we measure mass. We also measure volume. And finally, we measure length. The way that we measure mass is in grams, like I said earlier, because I was a deep-to-be, but that's all right. We all love me for who I am, right? We also measure volume in liters. We might recognize this when we talk about pop. We have a 2-liter bottle. So that's what we're talking about specifically with volume and liters. And finally, we measure length using meters. If you haven't realized, Ms. Perez has been talking about running my 5K, 5-kilometer meter run next Sunday. So that's a good kind of personal story to bring in the metric system, because even in races, we use the metric system because we recognize that 3.1 miles sounds much goofier than a 5K. Right? So when we're talking about the metric system, we have to recognize that these are our base units. So these are the things that everything else is based on. And as you move up and down, if you get bigger or smaller, you are just adding a word to the beginning or a prefix to the beginning of these base units. So anytime you're talking about mass, you're gonna have the word gram in there somewhere. Anytime you're talking about volume, you're going to have liters in there somewhere. Anytime you're talking about length, you're going to have the word meters in there somewhere, whether you put a centi in front of it or a kilo in front of it. So let's talk about that conversion and how we move up and down the scale of the metric system. So what you're going to do on your page is you're going to draw 7 steps. 7 steps. So to give you kind of an idea of what this looks like on my page, these are what my 7 steps look like. You can see that I went from the top to the bottom on my lines because you know how crazy I am about everything looking perfect. So what I'm going to do for you here is I'm going to draw those steps on the board. 2, 3, 4, 5, 6, 7. As you can see, I got a little janky at the end, but that's all right. So we have our base unit in the middle. So our base unit should be on this 4th step. We write base nice and big because we're all about that bass, no treble. Yeah, we're going to look back at this video and say, why did I just dance? And you're just going to say, Miss Perez, that's the way you are, okay? All right, so for our base unit, again, when we talk about mass, is grams. When we talk about volume, we're talking liters. And when we talk about length, we're going to talk about meters. Grams, liters, meters. Okay? So that's what that looks like. I'm going to scoot you up a little bit, make this a little bit more visual for you. There you go. So we have our base unit. Then we are going to go bigger. Let's go bigger, go home, right? So as you increase larger than your base, and your base is 0. That's our starting point, 0, okay? As we increase in size, we're going to call that a deca. Deca. Let me just check that deca is spelled right. Deca is with a K here, so D-E-K-A. When we talk about deca, we're going to add that to that base word. So if we have 10 grams, that's 1 decagram. We've got 10 liters, that's 1 decaliter. If we have 10 meters, that's 1 decameter. Okay, so when we're talking about deca, that is our tens place, our 10. Okay, that means we have 10 of something. Then we move on from deca, we add to hecto. Hecto starts with an H, so if we can connect that to 100, we will be 100. Hey. Just bear with me here. 100. Hecto is 100. And after hecto, we have a kilo. You may have heard this with kilogram, right? That's a very large measurement. It's actually what we use to measure the weight of a person because grams are really small. So when we talk about the weight of a person, it's often in kilograms. And when we talk about meters, right? Meters are a meter stick, which I'll show you during the lab. They're about the length of my arms. And when we talk about meters, if we're talking about a really long distance, like miles and miles of distance, we're going to talk about kilometers instead. And when we talk about the speed at which something travels in any other country, we're talking kilometers per hour, not miles per hour. So kilometers or kilo is 1,000. If you look here, notice how everything is getting larger by 10. 0 to 10 to 100 to 1,000. Okay? When we look at that, we have to see that this is progressively getting larger with each and every step up. So we go back to that base because we're all about that base. Now we're going to go down the scale. We're going to get smaller. So we have our base unit of a gram, and now we're just going to get a wee bit smaller until we're all the way to the point where it's like, whoa, why are we even measuring this stuff? But it's important in science to be as exact as possible. So we have our base unit of meters, liters, and grams. Now let's talk about our smaller units. So when we move down from our base unit, we go to deci, D-E-C-I, deci. That means things are getting smaller. This is our tenths place. Add that TH on there. So 0.1, 0.1. That's what we're looking at here, 0.1 for that deci. Then we move on to centimeters. We've heard that before, centimeters. And when we talk about centimeters, we realize that that is our hundredths place. So 0.01, 0.01 is our centimeters. And then if we go to the millimeters, we recognize that this is 0.001. 0.001. This is our thousandths place. Notice that this is 1,000. This is our thousandths. This hecto is our 100ths. This is our 100ths. Centi is our 100ths. Deca is tens. Deci is tenths. And then obviously we have our base unit. So something to realize is that we are going to have to convert some of these things to make the most sense when we're talking about numbers. We're not going to say that we have 2,750 meters. That doesn't make sense, right? So we're going to take it all the way to kilometers. And I'll show you how to do those conversions a little bit later. But when we're talking about moving between these different spots, we have to see what we can do to move from our base to our deca. So to move from the base to the deca, we're going to divide by 10. So for example, if I have 20 grams, I would have 2 decagrams. Do you see that? Because it takes 10 of my base to make up just one of these. okay? And then as I go up again, I divide by another 100. Or I'm sorry, divide by another 10. Divide by 10. And then as I go up again, I'm going to divide by 10 again. So if I have 1,000 grams, as I go up the scale, I should have 100 decagrams, 10 hectograms, and 1 kilogram. Okay. As we move down the scale, as we're moving down the scale, we are going to multiply by 10. So if I have 1 gram, I should have 10 decigrams. If I have 1 decigram, I should have 10 centigrams. So we're always multiplying by 10. And that is your conversion chart. Let me know if you have any specific questions, right? But the school day is starting, and I will see you all soon.